Hi guys, myself Dr. Chinju Krishna, Assistant Professor, Department of Mathematics, Christianity, Minima University. And today we are going to see the new topic, that is maxima or minima using second derivative test. First we want to know the working rules to find the maxima and minima using second derivative test. Let us consider a function y is equal to f of x. The first working rule is find dy by dx, then we have to put dy by dx is equal to 0 in order to obtain the stationary points. Second working rule, after that we have to find d square y by dx square, that is second derivative. Then the third working rule. In the third working rule, we have to consider part by part. Okay, there are one or two categories also. So first one, consider the first stationary point as x0. Then the second step, evaluate d square y divided by dy square at the point x is equal to x0. Then the third one, if d square y by dx square at the point x is equal to x0 is less than 0, then we have to come to one conclusion that f of x has a maximum value at x is equal to x0 and the maximum value is given by f of x. And the fourth one, if d square y by dx square at the point x is equal to x0 is greater than 0, then f of x has minimum value at x is equal to x0 and the minimum value is given by f of x0. And one more, the last one, if d square y by dx square at the point x is equal to x0 is equal to 0, then we have to say f of x as x is equal to x0 at the point of interest. So at last we have to see the working rule, repeat step 3 for other stationary points. The same step we have to repeat for getting the remaining stationary points also. And let us see two remarks, important remarks. Every point of maxima and minima is a stationary point, but the converse is not true. And the second one, at the extreme point x is equal to a, the tangent is always parallel to the axis. These two remarks we have to keep in mind while doing the problems. So let us see first example. Determine the maximum and minimum values for the function x cube minus 6x square plus 9x plus 15. We are going to find the maximum and minimum values for the given function. So solution, let us take the given function as y. So let y is equal to x cube minus 6x square plus 9x plus 15. Then according to the working rule, first working rule says we have to find dy by dx. So for the given function, we have dy by dx is equal to 3x square minus 12x plus 9. Then also we have to find d square y by dx square, that is 6x minus 12. Then according to the working rule, we have to get the stationary points, means we have to put dy by dx is equal to 0. So when we put dy by dx value as 0, we will be getting two x values, that is x is equal to 1 and x is equal to 3. Now my first stationary point is 1 and the second stationary point is 3. So then I am going to find, using the first stationary point, we are going to check it is a maximum value or minimum value, and if it is a maximum, we have to find the value also. If it is minimum, then we have to find the minimum value also. So using the first stationary point, I am going to verify it. Okay. So first one, at the point d square by dx square at the point x is equal to 1, we have to substitute in the place of x is 1 in the we have found already the values of d square y by dx square. So if I am substituting x is equal to 1, I will be getting the answer minus 6. So if I want to compare with the 0, that is less than 0. So according to the working rule, it says if the value is less than 0, then our given function has maximum. That is maximum at the point x is equal to 1. And the maximum value is given by y at the point x is equal to 1. Again, we have to substitute the given function in the place of x, we have to use 1. So if you are substituting x is equal to 1 there, we will be getting the answer 90. So I came to the conclusion that we have y having maximum at the point x is equal to 1 and the maximum value is given by 90. Like the same manner we have to do for the second stationary point, that is x is equal to 3. If so also d square y by dx square at the point x is equal to 3, we will be getting the answer 6. So when we are comparing to 0, that is greater than 0, so I can conclude that y is minimum at the point x is equal to 3 and the minimum value is given by y at the point x is equal to 3, that is value 15 after the simplification. So the maximum value is 19 at the point x is equal to 1 and the minimum value is 15 at the point x is equal to 3. Likewise, we can see one more problem related to this one, maxima and minima. Second example, determine the maximum and minimum values for the function f of x is equal to 2x cubed minus 15x square plus 13x plus 10. As usual, for the first solution, we have to write the given. Here f of x it is given, so we have to write f of x. F of x is equal to 2x cubed minus 15x square plus 13x plus 10. According to the working rule, first we have to find the first derivative, that is f dash of x is equal to 6x square minus 30x plus 36. Again, you have to find the second derivative for our calculation. So that is f double dash of x is equal to 12x minus 30. Again, we have to use the working rule. We have to put the first derivative as 0. So we have to put f dash of x is equal to 0. So that means the value, that is 6x square minus 30x plus 36 equal to 0. After doing the simplifications, that is solving the equations, we will be getting the two values for x. That is x is equal to 2 and these are the two stationary points. Now my aim is to get, we have to check for the first stationary point the given function having maximum or minimum value. Likewise, using the second stationary point, we have to check the given function having maxima or minimum value. Okay. So I am taking the first first stationary point x is equal to 2. So that is f double dash of x at the point x is equal to 2. We will be getting the answer minus 6. So that is less than 0. So I have to come to the conclusion that f of x is maximum at x is equal to 2 and the maximum value is given by 38 after the simplifications. Likewise, we have to go for the second stationary point, that is x is equal to 3. There I will be getting the value 6, that is minimum. So I came to the conclusion that f of x is minimum at the point x is equal to 3 and the minimum value is given by 37 using the same simplification. So here we will be getting the maximum value is 38 at x is equal to 2 and the minimum value is 37 at x is equal to 3. So likewise, we have to apply the working rules for the maxima and minima of the second derivative test, and we will be checking the given function having maximum values or minimum values. And if it is a maximum, we have to get the maximum value. If it is minimum, we have to try to get the minimum values. Likewise, we have to do the problems related to this category. So thank you.